So I'm Paul Martell, Education Services Manager, and I'll be your presenter for today. And David Fowler, Technical Enablement Manager, is manning the question queue for us. So as I said, if you have any questions, please feel free to type them into the question queue. David will be answering a lot of them. Some of them will get marked so that I'll mention them on air as well. But please take the opportunity to use that for anything that you feel you need any clarification. So in this session, we're going to be introducing Actifio's SLA Architect to set up Actifio policies to protect your data. We're going to begin by looking at how often the data will be protected, where will the data be stored, the quick access to the data via snapshots and storage optimization via Dedup, and how long you'll be retaining that data. So let's begin with a simple definition of what is data protection. We define data protection simply as being the copying and the archiving of computed data so that it can be used to restore the original after a data loss event. Now, a data loss event can be defined either as deletion or corruption. But you can also use it to make other copies, and it's one of the great features of the Actifio product is that you can create test dev copies, QA, analytics, as well as protecting it so that you have that information should something happen. Now, for any data protection platform, there are 4 basic questions you want to consider. The first being, what do you want to protect? Next, when do you want to protect it? Where do you want to store it? And how long do you need to keep it around? Within Actifio terms, we can take these 4 and define the what within the application manager as part of application protection. And the when, the where, and the how long are all a part of the SLA Architect. In our terminology, we define when as policy templates, the where is resource profiles, and the how long is the retention period. So what is a policy template? Well, a policy template is simply a collection of policies defined within the SLA Architect. Each of these policies will define how the copied data will be managed by the Actifio appliance, and the policy comprises the type of backup operation, snapshot, dedup, replication, etc. The frequency or how often the data will be protected, and the lifetime or retention period of the backed up data. So, how often do you want to protect your data? Once a day, twice a day, every other day? You have to decide when you want it protected. The first of those being the hours of operation. This is the window in which the type of backup operation you're defining will take place. You set the hours of operation on the chosen days with independent frequency and retention periods. You want to make sure that the window is of sufficient length to complete all of the tasks. For example, for a snapshot operation, let's draw a clock, label it with the hours, and let's say that we're going to set the window of operation to be from 1900 to 7 within the system. This defines to us when we will begin and end the operation. And we can look at one for dedup, for example. Same thing, let's take a look at a quick clock. And we'll set the hours for this one to be primarily the whole day. So we're going to start at midnight and end at 23:59. Now, one of the critical things about our application is there actually does have to be a 1-minute gap. That's the maximum you can do is 23 hours and 59 minutes in the day. The system must know exactly when the start time is and when the stop is, and they cannot overlap. Now, when you place an application under protection, that application is listed under the policy template that you have defined. When the window opens, we begin protecting the data. Now, the apps are actually processed in a random order. So if I have multiple applications that are scheduled to run at the same time and with the same job priority, the selection of the application to run is randomized to ensure fairness across all of the applications of the same priority. This is so that we don't have a situation where the same app is always the first one or a particular app is always the last one. But what happens if we don't complete all of the jobs, that the window closes before everything is processed? Well, by default, we process 6 concurrent jobs in the snapshot pool. That is actually a parameter which you can change on the desktop UI, and in fact is part of our seminar next week, Smart Capacity Planning. Now, there are reports, of course, that are going to help you with this. So there is a report that lists job failures. The issue that we have here, though, is that if the window closes before we can complete all of the activity, then the job that did not get processed did not fail because it didn't run. So it's not going to show up on the failed jobs report. That report will list any jobs in which we attempted to perform a task and were unable to do so. Instead, those jobs are going to be listed on the SLA violations report. It is a violation because the job was scheduled to be performed during the hours of operation, but we were unable to do so. So here we see what we refer to as the policy map. The arrows that you see make up the policy path. So these green arrows indicate to us the individual policies within the template. The dark green arrows indicate to us that we actually have a policy in place that has been defined for that stage. The lighter green arrows indicate that there is no policy, either because it has not been defined or it cannot be defined. So a policy can be made up of one or more of the following policies within the system. First, the production to snapshot. Now, this policy defines when and how often the production data will be captured and how many snapshots will be retained. Data recovery from the snapshot pool is fast because the images have not been deduplicated. They are still stored in the local snapshot pool and is designed for short-term retention. The snapshot to dedupe backup policy defines when to deduplicate the snapshot data and how long to retain that data. Now, data in the dedupe backup pool is meant for longer-term retention. If you take many snapshots in a short time, you can dedupe the snapshots sometime later on. This prevents the dedupe jobs from competing with the more time-critical snapshot jobs for resources. We also have a policy which is referred to as production direct to dedupe. Now, this defines when to dedupe VMware VMs directly from production data. And again, you get to specify how long you wish to retain that. Capturing VMware VMs directly to the dedupe pool is designed, again, for that longer term when instant access to a snapshot pool is not required. Next, the dedupe backup to dedupe DR policy defines when we're going to replicate that deduplicated data to a remote Actifio appliance's local dedupe pool. And again, we'll specify how long that data will be retained in that pool. Sending data to the dedupe DR pool is meant for retention of the data in case there is a disaster at the local appliance's site. We also have the ability to go to a second leg, to another remote replication in a multi-hop replication scheme. This enables you to store a deduped image from the primary appliance, my local system, to 2 remote appliances. The snapshot to OnVault policy allows you to replicate data to an OnVault storage pool or the cloud. And then we have a special one, which is production to mirror. Now, this one defines how data will be replicated to a mirror pool. It's actually the snapshot pool on the remote system. Now, the data in this pool is meant for instant recovery in a disaster recovery scenario. So when creating for a policy that runs production to mirror, you can choose two different types of replication. The first one is called Dedup-Async replication, and that actually uses dedupe processing for a bandwidth-efficient replication. The data path will actually follow production to snapshot. It will be deduplicated, sent across and replicated, and then rehydrated back up to the snapshot pool. Another one is Streamsnap replication, and what that allows for is a point-in-time snapshot of the original application without performing the dedupe operation. Once we have the when, then we have to define the where. Where do we want to store the information that we're talking about? Well, the first is local snapshots. Now, local snapshots provide you with a local instant incremental backup of the system, and it is represented on our map by the snapshot pool indication. Local dedupe, of course, again, was for that longer-term local retention and is shown as the dedupe backup pool. Remote dedupe, as I said earlier, long-term remote retention at an offsite location and is represented by the dedupe DR pool. The important thing to remember here is that this dedupe pool is local to the remote system. In some scenarios, customers actually use a business continuity model in which the local system, I'll pick a location, is in Boston, and I'm taking my production information, I'm snapping it, I'm deduping it, and I'm sending it across to my Chicago system. But in Chicago, they actually have a production system to the snapshot pool, to the dedupe pool, and they're replicating it back to me. That means that the dedupe pools at each site must be capable of storing all of the local dedupe information as well as the replicated information coming into it. The mirror, as I said, is a snapshot pool at the remote site. And OnVault is the cloud. When you set up an OnVault pool, what you're doing is you're defining the information necessary to access that system. Say I'm using AWS. I would define all of the parameters necessary to speak to that system. And when we go to move information into the cloud, we actually use the Vault pool as the indication of that information. Our newest release of the Actifio appliance, 8.0, comes with 8 sample templates. The names of these policies, as you see here, are prefaced with the letter Z to make them appear at the bottom of the list. Our list of templates is alphabetic, so therefore this keeps them down near the bottom. The sample templates can be used as is, or you can modify their policies to meet any application requirements, as well as the fact that you could create new templates and policies if you so desire. Now, we use the SLA Architect's designer to view, to modify, or create the policy templates that the Actifio appliance will use to protect your data. We refer to the center section here as the data protection map, and again, the green arrows indicating the data protection path. The most common way of creating a policy template is actually to clone one of the existing samples. To do so, you simply select the sample that you want, whichever one closely matches your intended results, and then you right-click on that to display the service menu. When the menu is displayed, you can then select Clone. The system will create a clone or copy of that template. One of the first things you're going to do is change its name. Here I've named it Daily with DAR. The template that I chose uses the mirror capability, which is Dedup-Async Replication, or DAR for short. Now, when we double-click on one of the arrows, we open up the Policy Edit dialog box. Within this, you have the ability to first change the name as well as the priority if necessary. If you note, the medium is the defaulted priority for all systems. You have the ability to change it to high or low. Next, you can set the policy schedule. You can either choose windowed, as you see here, which uses a time window and frequency, or you can use continuous. If I select window, then I next get to select when the policy will run, daily, weekly, etc., as well as list any exceptions. One example of a common policy in use is to run every day except Saturday and Sunday. Next, I specify those hours of operation and how often I want to run within that window. And lastly, how long am I going to retain those images? When we're dealing with the snapshot pool, we don't want to have those images remaining in the system for very long. The snapshot pool is designed for quick recovery, and it's really the dedupe pool where I want to pull information. If I use the continuous selection, then I also get to specify when I'm going to run, so this will run every 24 hours, as well as indicating when the jobs will start. And lastly, how long I'm going to retain those images. Once I've made the changes that I wish to make to the policy, I then want to select the Project Changes button. What this is going to do is it's going to show us the effect that the changes you have made will have on the policy. So here I can see that prior to making any changes, I was going to keep 2 copies per volume. After the changes, it's remaining at 2. Had I gone in and said that I wanted to run it every 8 hours, then I would have changed this number from 2 to 6. One of the key things to remember about this is the fact that this is displaying per volume. So if I have 100 applications and there's 1 volume in each, then that means that I'm going to have 200 afterwards, right? I'm going to have to be able to keep track and monitor how many I have. The system does have finite resources in terms of, first of all, the pool space, as well as the number of VDIS, the indicators that we use to track all of the snapshots. That information also will be covered in next week's webinar, Smart Capacity Planning. So when I'm all done, I'll have my completed template. I've cloned it. I now can assign it as needed. So earlier, we looked at the different places where you can store your data. And those were listed as the local snapshots, the local dedupes, the remote dedupe, the mirror, and the vault. So let's look at some of the best practices for each of these. Now, these best practices are contained within the sample templates that we provide. So for example, the production to snapshot policy, I have the choice of setting up a windowed schedule in which there will be 1 snapshot per window. So the window will open as needed. Now that may or may not span the day boundary. In the examples here, the default is 1900 to 1700 hours. So that does span midnight. We actually refer to that in our system as midnight madness. The reason that's of concern is simply when you're looking at certain reports, you do want to remember that I either have to look at the window or I'm going to look at a calendar. So some events may not look like they occurred because they occurred after midnight on a different day than when they started. The frequency, as you can see, is once per window, and the default is for 2 days. I can also set up one, which is a windowed schedule, but with multiple snapshots per window. Again, the window will open as needed, and the default for this is 1900 to 1700 hours. The frequency also is as needed, and not to overlap with the time to take the snapshot. The default is every 8 hours with a retention of 2 days. And the third choice within this is a continuous schedule, which will run daily at regular intervals. So in this case, the continuous schedule spans a single 24-hour boundary. The frequency will be as needed, but again, not to overlap with the time it takes to snapshot. The default is every 8 hours, and obviously you can change that with a retention of 2 days. Moving on, the snapshot to dedupe policy gives us windowed as its normal default. Right? This one here also, the window will open as it's needed. The default, though, is set for 1900 to 7. And that's one of the things that you also want to pay attention to. And that's typically, you want the time frame, the windows in many of the policies to be the same. I want events to take place. The reason for that is I want the deduplication to take place as soon as possible after the snapshot is taken. So having the window set for the same hours of operation assures that that's going to happen. The frequency, once per window, and the retention period is defaulted for 14 days. I also can set it up in a continuous manner. Again, it will span a 24-hour boundary, and you will define when that first job will be, in this case, 1900 hours, and it will run every 24 hours with a 14-day retention. For our dedupe backup to DR policy, we also have windowed as the default. Again, just like the others, the window will open as needed. The default is the same time frame, the frequency once per window, and we're going to retain that for 14 days. I can select continuous. Same as the others, continuous will span the 24-hour boundary, but the first job will start at midnight instead of 1900 hours, and it will run as needed every 24 hours with a 14-day retention period. We have the ability to snap and go to OnVault, our cloud capability. Now here, the window will open as needed. Will open as needed, and all of the storage will be defined within the pool window. So you have to enter in all of the various parameters, as I said earlier, for your cloud access, my login credentials, the information I need so that I can access that pool. On our system, we will display it as the OnVault policy, and you can see what's in those pools. Next one on our list, dealing with the mirrors, we have, first of all, Dedup-Async replication, often referred to as DAR, and this is also a continuous one. The schedule will span a 24-hour boundary. It will start at midnight, run every 24 hours. And the retention period can be set for whatever you need. Now, the key thing here is the process by which we do this. So you have to understand that the Dedup-Async replication will actually take a snapshot of the data. It will dedupe it, will replicate it over to the remote appliance, and then will rehydrate that data on that remote appliance. It will then update that full copy of the data in the snapshot pool, ready to be mounted in the case of a disaster. Streamsnap. So Streamsnap is a replication of the snapshot data to the remote appliance without any deduplication taking place. It does require a high-quality network, and you can provide RPOs, recovery point objectives, as low as 1 hour. The Streamsnap policy, though, is specifically tied to the schedule of our snapshot policy. and therefore will use the schedule and frequency settings of that policy. The main thing about it is with the DAR option, where we have information in the mirror or remote snapshot pool, we can only have one image. So if I set an RPO at 4 hours for DAR, what happens then is that I'm going to take the image, I'm going to snap it, dedupe it, send it across to the DR site, rehydrate it into the mirror pool. 4 hours later, I'm going to follow that process again. I'm going to take another snapshot, dedupe it, send it across, replicating it to my DR site, and I'm going to rehydrate it, replacing the image that I currently have. With Streamsnap, one of the things we gain is that we can actually store multi-point-in-time snapshot images. So if my snapshot policy is to retain up to 2 days, and I'm taking images every 8 hours, then I'll have 6 images in my snapshot pool. If I have Streamsnap set up, I'll have the same 6 images in my mirror pool, which is the snapshot pool at my remote site. Again, for disaster recovery. So in this session, I've talked about how to apply these policy templates to ensure that you meet your technical and business objectives, specifically talking about how often the data will be protected, where you're going to store it, which of the pools are you going to use to place the information, the quick access to the data via the snapshots or storage optimization via the dedupe, and lastly, how long that data will be retained. Now, one of the things I want to point out is the process of taking a snapshot is where we're impacting your network, where we're actually touching your infrastructure. We're taking your production data, and our initial ingest will be the entire item that we're snapping. So if I have a 300 gigabyte VM, then I'm going to bring in that 300 gigabytes. From then on, we do incremental forever. I'm only capturing the change blocks, but I am synthesizing a point-in-time copy within the snapshot pool. Again, because data that I need has a tendency to be discovered quickly, that being somebody realizes that they deleted something, and so they call up the help desk and say, "Can you bring that back?" I'm retaining information in the snapshot pool because it's in the form that I need it. It's ready to be mounted. It's very quick. Within a matter of seconds or minutes, I can have that information mounted into my device, and I can go in there and actually drag and drop or do what it takes to recover the information. The dedupe pool is really the recovery objective that I'm looking for, setting a time limit of we can recover information up to 14 days as the defaults are in our best practices. So that means that for the first 2 days, the information is in the snapshot pool. But because it's in its major form, it takes up a lot of space in that pool. That's why I don't want to keep all of my images there. So I dedupe it. By deduping it, what we're going to do is we're going to look for any blocks that are duplicated in anywhere else within the system. The example that I use all the time is pretty simple, and that's if I was to create a Word document and you were to create an Excel spreadsheet, tonight's backup image is going to contain those because they're brand new. So that's going to be in the change blocks. And that information is going to be taken from the snapshot pool down to the dedupe engine. So we'll say it hits my Word doc first. So we're in the process now of going through my document block by block. And it just turns out that none of the blocks are duplicated anywhere else. No problem. We're going to store that information. Not only do we look for dedupe, but we actually compress things as well. Now it gets to the point, now it goes to do the next part of the image, and that part of the image is your Excel spreadsheet. 2 different applications, could be on 2 different systems, brought into the Actifio appliance via the snapshot policy. So it gets to your Excel spreadsheet, and it starts looking at it block by block. And all of a sudden it hits a block, and it just happens, even though it's an Excel spreadsheet, that all the ones and zeros in that block line up to match one of my blocks in my Word doc. The ones and zeros are exactly the same. Rather than storing that block twice, once in my Word doc, once in your Excel spreadsheet, instead what it's going to do is it's going to maintain a simple pointer within your spreadsheet saying that block is located here within this other document, within this image. Now that is a pretty simple example of what we can do, but if you look at something like a mail package, where if I took a photograph, for example, and sent it out to everybody who's participating in this webinar right now, then that means when we're all on the same web mail server, and tonight's backup, it's going to look and say, oh well, here's this image, and it's in Paul's sent directory. Oh, and here's this image, and it's in so and so's inbox, and somebody else has actually filed it. Another person saw it and trashed it. It's in their trash. So what we end up having is, just looking 10 of us. So what's going to happen is within the snapshot pool, we actually will have 10 copies of that image. But when we go down to dedupe it, we're going to look at it and say, wait a minute, these blocks all match. So therefore, we'll store one copy of it. Now, if that happened to be a 1 meg file, look at the impact that we have. In the snapshot pool, there's going to be 10 megs of space utilized to store that. If I was to retain that for a long period of time, then add that 10 meg to tomorrow, somebody actually took it out of their trash, but 8 of us didn't, whatever. You could end up with using a phenomenal amount of space. By deduping it, we're only going to store 1 meg of that. The rest are little tiny pointers that maintain where that image is stored. That's the efficiency of dedupe. Now we take that image, as I said, snapshot down to dedupe. Now we're going to replicate it to our remote site. So once we've taken that image, we've deduped out, we've compressed it. Now when we go to replicate it, we know the information we've already sent across to that site. So we're only going to send anything that is different, just the deltas. So again, we reduce the amount of information that has to move and be stored at the other location. When you need to go and recover a file, you're always going to look first in the snapshot pool, see if it's there. If the image is not there, the next step would be to go to the dedupe pool. Now, when you go to a replicated site, you have the option of keeping the retention period the same or making it longer. A very traditional one would be to snap for 2 days, right? Dedupe it for 14, and perhaps keep it at the remote site for 30 days. You have the option of setting these to determine how long you want to store it at each of these storage locations. What are your specific recovery point and recovery time objectives? And that's what you want to build your SLAs to do. Now, the SLAs are living, breathing documents in a way. You do have to monitor what's going on with the system. The failed job reports, the SLA violations being 2 of the great reports, to tell you as to what's happening with processing the information. Because what you want to be aware of is that the SLA window, the hours of operation, need to process all of the jobs. If you add more and more jobs to that, you run the risk that you cannot complete all of them in time. Now, any job that is running will run to completion. So if I have it set for 1900 to 7, as an example, again, at 1900, we're going to start processing our randomized list of the jobs that are being protected by this template. We're able to run, by default, 6 concurrent jobs. So I pick off the first 6, I start processing. As soon as one is completed, I grab the next one off the list, and I keep cycling through until I have protected all of them. Again, if I keep adding more and more devices or more applications to the system, I run the risk that I'll hit the end of the window and not have some of the jobs processed. Now, any job that is in play will run to completion, but no new jobs will start. That's a major part of capacity planning, and that's what next week's webinar continues on with. To talk about those resources that you need to keep an eye on when you're looking to increase the capacity, the activity taking place on your Actifio appliance. So hopefully I've given you some points and information about the applications and the appliance itself that you were not aware of. We will take a moment to see if anybody has any questions. Please take the time to type in a question at this time. Just looking to see a couple people look like they might be starting to enter something. Give just a bit of time here. If you have not looked at the question queue, you will see that there was a question someone asked about the recording. This session is being recorded, and we will be providing a link and a job aid handout a little later on. Giving just a moment here. A couple questions coming in. While we're waiting for people to type, once again, I'll remind you that as soon as this session ends, you will be presented with a very short survey. It's 5 questions. If you could take the time to do that, we really do value your input. Particularly the last question actually is suggestions for additional webinars in the future. We have a list of about 8 of them, I think, currently in the queue, but we're always looking to see other topics that would be worth bringing up. Okay, I see David's answered the question that was there. I'm not seeing any other questions coming in. Actually, I'll probably talk about this. I'm just waiting a moment here. So it's a question dealing with the process that actually takes place to do the snapshot. So the answer is there is a little bit of a difference depending upon whether we're using an Actifio connector to speak to the device or whether we're using VMware VMs. In the case of VMware, we actually use its APIs to do things. So in some cases, we're simply going to the device, in VMware as an example, we're going to the device and telling it we need a snapshot. So it does its normal snapshot operation. It provides us with that information. We create a staging disk within the snapshot pool that contains the initial ingest of all of the information. If it's a thick provisioned VM, for example, and it's 300 gig, then we will actually create a 300 gig staging disk. Once we've done that, from that point on, we now go into what we refer to as incremental forever. So the next time I need to take a snapshot of that same application, I'm only going to capture the change blocks that are part of it. And I will use that and basically apply that to the staging disk to create a new point-in-time image. Contained within our Sky Administration training class, which is held on 5 consecutive afternoons. And that's that class I was talking about. If the next one scheduled is January 22nd, there's also one, I think, February 12th. If you go to your Actifio Now customer portal, you can log in there for live instruction and register for one of those classes. And we actually go through how this process is handled for the different types of devices that we're dealing with. Okay, so I'm going to say thank you for those of you who attended. We do appreciate it. Again, once I close the session, you will see that there is a survey to be completed, 5 short questions. Please take the time to do so. It is only through your input that we can actually enhance the quality of our programs. Again, thank you and good day to all of you.